Hello students, in this video let us see the chapter 3 of first unit of Fundamentals of Information Technology. And this chapter deals with the components inside a computer. When we say the components inside a computer, we typically mean that the CPU that we have seen. So what are the things that this CPU actually has inside it? See, a computer performs a lot of functions. A lot in the sense, a lot of functions. So, to do these things, appropriate hardware assistance is needed. Otherwise, you can never have the computer working the way it is working. So, it's like, see, our body has eyes, ears, nose for all, for receiving sound, to see the visuals, to get the smell, right? In the same way, computer has to need some of the hardwares, okay, or the parts inside a CPU that actually helps the computer to get the information from outside, process it, and again send it outside, right? Inside the computer, whatever the things we are giving is processed and again it is given out as an output. So to do these things, there has to be, the very separate set of hardwares and tools inside a CPU to help this function. So mainly we'll be seeing the CPU case and what it has. So this is a typical CPU case that we have, and it includes the first thing is the power supply. You might have seen there is a fan inside a CPU that we can see at the back of the CPU. So that is a power supply. Simply we can also call it as a SMPS. Then a motherboard. Motherboard usually has all the things that has been a computer has to work, that is needed for a computer to work. So CPU cooled by the computer fan. There is a separate set of fan for the system to be cooled. There is a hard disk, there is a CD drive. So this is the front part actually. So here we insert our CD, DVD, or even the pen drive. Pen drive can also be inserted from the back, right? So this is inside of a CPU, and it has a graphics card, PCI buses. But let us see what are all these things in the coming slides. But why actually a case is needed? See, this is the case. Inside this case, all these things are mounted. See, in a particular places wherever it is needed, so it is mounted. So this is the motherboard, and these are the rest of the circuitry inside the CPU. So why these are the ribbons? Why do we need this? Why a case is needed? You can simply have it as a, different parts could be just kept like that. Then why do we have a case? So there are uses of this. So that is, rule of a system case is, first thing is a structure. Structure is, it gives a definite outline, right? Inside this everything should be mounted. So you might have seen nowadays the CPU has become very small. Okay, rest of all these things are even again mounted, but still the system case is small. It has, the better options or better parts inside it, so that is why that small size could be made small. Again, protection from what? From dust or from the dirt, from spilling of something on it. So it provides kind of a protection to the components inside the computer. The main thing is the cooling. Why cooling? Why do we need the system to cool? See, when the tools inside the systems is working, or the components inside the CPU is working, a lot of heat is generated. A lot of heat. And these motherboard or other components, they're all tiny components, and they get heated up very easily. So to reduce this, and once if it gets heated up, your system is not going to work, because it behaves differently. A semiconductor, whatever is there that has been mounted to the system, if it is not working in the room temperature, or the below the room temperature to certain lower temperatures, it will behave differently. So it will be no more a component attached to a motherboard. So that is why cooling is very 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 necessary. So what happens, this case itself acts like a cooler. The thing is, like, whatever the heat is generated inside is always put outside through these fans. Either it could be this fans or it could be smps fan. Okay. So next is organization and expandability. Organization in the sense, see, it is mounted in an organized way. It is not simply, it's not just not put inside a case and it is locked. No. See, here it is for the drivers, here it is for the motherboard, here it is for the smps, that is power supply. So everything is organized inside a cpu. Next is a status display. Status display is nothing but when you on the PC, usually you see a led light. Either it could be red, green, sometimes it's blue. So this defines a particular thing about the CPU, like whether the CPU is ready to work or is there any problem. You might have seen sometimes the CPU makes a sound, a small tone is, it's always giving that tone. When does this happen? This happens only when the sys component inside a computer is not working properly, especially the RAM. You can hear a sound, a long sound. Okay, a very subtle one, but still. So you can make out then the hardware inside the system is not working. See, if it is a software, it will always give us a message like this thing is not working, this is not working. But what if the hardware itself not working, like the system cannot get on itself? Then this is given by these led lights and the sound that it makes. So this is the use of a case. Let us see one individual components one by one. So this is how a smps looks. If it is taken out of a cpu, it looks like this. So you might have seen this is where we insert the plug of the computer, and from this it is connected to the power supply. So this smps, that is power supply, the full form is said as a switched mode power supply. It is a transformer and a control device in a computer. So what does it do? It converts the AC. You know, our electric lines for home and office use is an AC line, right? That is converted into a low voltage DC supply. And you know, a computer does not need high voltage, right? The voltage that is required by a computer is very low. So this AC is converted into low voltage DC. And what does it do? It's not just taking the current from the supply, but also inside it is making it such a way that every part of the motherboard or other peripheral devices and memory unit, whatever it is, which needs a very 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 small amount of voltages, it is converted with the help of this smps. And there is this fan. This fan actually helps for a cooling of the system, smps, as well as even if the extra heat is generated on the cpu case, that is also removed by this fan. So that is a cooling ability. Next is expandability. Why expandability? Because when it is converted into low voltage dc, if at all you add some peripheral to the computer that requires a little more of voltage, what does this smps do? It draws that voltage and converts and supplies to that peripheral. So that is expandability. That is, your computer is not usually is not working usually with that kind of voltage or that kind of peripheral device, but when it is needed, you can add a peripheral device and you can work with this. So that we call it as a expandability. Next is the motherboard. So since the name says motherboard, right? What is a motherboard? It is nothing but actually the system board. We simply call it as a motherboard. It is actually a multi-layered printed circuit. You might have seen, see, there are no wires here, are there? But do you think these things are not connected to each other? No, of course they are connected. How? See, you can see these are the printed things. See, they have written, there are, see, these are the small semiconductors. See, these are the capacitors. Okay, so what does these do? This there is a circuitry in below this, like here in this, below this line. So these things are connected to each other with that circuitry. And this is a plastic board, whatever you can see this blue thing, actually it's a green, sometimes usually it's a green color one. So this is a green circuit board, plastic circuit board, and underneath there are the wires which are connected to each other. So all these components are actually connected each other. And there are main three things that you need to know, that is BIOS, CMOS, and the chipset. We'll see rest of the things also in this. So how does it work? So what is a BIOS actually? BIOS is nothing but startup instruction is sent to this drive, or it is a set of several routines inside the room that gives two advantage to the computer. That is, first one is the code, the data in the room BIOS need not be reloaded each time the computer is started. When the computer is started, it itself loads the program, right? It itself gets on. And secondly, they cannot be corrupted by the way, if the other applications working and something happens to this, so BIOS will not be disrupted. That is why it has a separate BIOS in the system. Okay, that is the use of BIOS. BIOS is actually for the starting up of the computer. Okay, so after that we have the CMOS. See, CMOS battery backup is here. So what is the CMOS battery backup? See, it includes a complementary metal oxide silicon. It's a full form of CMOS. Okay, so what it does, it consumes a very low power and it is kept alive with the battery. Why it is done? Because see, the date and time, even if you switch off the computer, will be working all right. You don't have to set the date and time every time you on the system, do we? No. How is that possible? Because it has its own separate of battery. So it has a small memory capacity which has like important data, like mainly the system date and time, that is a clock. And it all these things are actually uh, integrated together to form a single chip. So even when the computer's battery is off, so it will be working on its own. So that is a help that the CMOS does. Okay, so it is usually for the computer's basic configuration. It could be like hard disk, floppy disk, what are the memory capacity of the system. All these things are stored in this CMOS. Okay, yes. Then next, what are the things that we have? We have so many things in this motherboard. So what are they? It has a peripheral for the keyboard, mouse, serial port, USB, Ethernet, audio, all those things, right? For mic, for speakers, for it for the slot from the power supply, everything is here. So that these are the peripherals that we add to the system. Okay, then what else? See, this is the slot for a RAM, that is DRAM memory slot. Okay, there are usually two set of slots. So with the help of this you can have the RAM in this. Then this is the CPU socket, or it is also called as a chipset. Chipset in the sense, here we are actually adding the processor or the microprocessor that we are using for the system, right? Then see, there are like heat sink. This is a heat sink, that is, this motherboard produces a lot of heat while it is working. So to reduce this heat and transfer this heat, there is a heat sink. Then there is AGP slot. What is this AGP slot for? It actually has an integrated audio for the audio socket, that is to get the audio to the either you can add it to the speakers or you can add it to your system itself. So there is a AGP slot. Then there are a few other things that is for the connection inside the system. that is actually helping. See, this is a for CPU fan and heatsink mounting points. That is, you can add a fan for this so that the system actually cools down and the fan works inside the CPU. So this is how a typical motherboard looks like and the things that is present here. See, I've seen, you can see there are so many slots here, right? And these are not the same. There are different slots and different uses for them. We'll see this one by one. So this is actually a block diagram of the system. So this represent the BIOS, and this represent the microprocessor and the heatsink, and these are the connectors for the USBs you have here, that is here. And so there are so many, fan connector, then drive connectors, all these things are represented here. And this is for yeah, fan connector and memory connector. So fifth is this is for the power supply. For the motherboard you need powers, right? From the SMPS there is a there are wires that attach to this point. So this is the block diagram, how actually it looks like. So in the previous slide we have seen, I told you there are various slots, right? So this PS2 port is for the mouse and keyboard. So the mouse and keyboard in the desktop are attached through this port. Okay, that is PS2 port. So the you can see the structure is different than what it is for the other things, right? So it is mainly for the keyboard and the mouse. So next is the serial port. Serial port is the one which transfers data serially. That is, one after the one itself, the data has to flow from this port. So initially it was used for the cameras. Later on it was not faster, because serially, when we say serially, it has to be sent one by one. It would be late, and so that is why it was just used for in some cases for the mouse and the keyboards. Next is the parallel port. You can say that parallel ports are usually faster than serial ports. Why? Because it usually sends 8 bits of data at the same time. You don't have to wait for one by one. It actually sends 8 bit of data at once. And so because it transfers at a time, it is faster, and it is used in the peripheral devices such as printer and the CD-ROM. Okay, so to read the data for the to send the data to the printer or read the data from CD, we use this parallel port. Next is the SCSI port. SCSI is the name of the company, and the port is a mixture of both serial and parallel. So now why is this used? It is usually for having the data to be sent up to 7 devices. Okay, that is, even for if it has to reach the 7th device, of course it has to pass to the first 6 device and then to the 7th. But these ports are usually hardware interfaces, like which include expansion board that plugs a computer called SCSI host adapter or SCSI controller, that is actually connected to a hard disk drive and network drives. For that purpose we have this slot or the port. So after these ports, if you want to get some more extra from the motherboard, or you want to have enhanced facility for the system, that is, see, it has a basic card slot in the motherboard, right? For audio, for video, for the network to access the network, for the modem, for the PC card, everything. But you have to insert this card as an extra tool for your system. It will not be there by default in the motherboard. So what we actually these expansion cards do, these are also called as the adapter card, and it provides additional capabilities to the system. That is, like, for example, you want enhanced sound, you want enhanced video, the graphics in your system should be a very profound one. So what you do, you use these extra cards so that your PC will be working better. And of course, again, the related hardwares also should be upgraded when you use this. Okay, for example, if you're using a sound card of a high quality or a high end, then again your speakers have to be of a high end, so it follows that way. Okay, so we'll see one by one. That is, first is the sound card. So sound card is an expansion card that allows the computer output sound through the connected speakers, to record sounds from a microphone and to manipulate sounds. That is when you are actually editing the sounds. So you need this card so that you get a very high quality audio. Okay, and it contains special circuits that operates the system sound, and allows playback and recording of the system from the CD-ROM. So to get the enhanced sound, the uh, audio and as well as sound to this from the speakers, we need this sound cards. Next is the video cards. So what does this video card do? Video card, it's called the display adapter. That is to display the graphics on a enhanced mode on a computer monitor, and it converts the images created in the computer to electronic signals required by the monitor to get a high end video. Okay, so you might have seen some of the videos that are the monitors that are actually with the high definition. So you need a video cards for that. For the, if you are using a laptop or a computer to get that, then you need to use the extra video card to it. Next is network interface card. See, system has the capability in to connect to the system present near it. We call that as networking, right? To have this property, or to have this networking in the system, we need to have a network card. So what is this? These are like the accessories that you've been using to the system. So if we have the network card, you can connect your system to the other computers in the network. So it actually gives a connection between the LAN network to the system, and to have a full-time connection to a network. One more is modem. See, now modem one is present in outside, we call it for the internet to be accessed. There is one more modem that is present inside, that you can add this modem. So what does it do? It actually gets the internet connection through phone lines. Okay, it converts digital data from the computers to analog and transmits over a telephone line. So nowadays these things are inbuilt, like you get these things inbuilt to the motherboard itself, but you can also use this enhancing card for the same effect. Okay, and the speed of this modem could be up to 56 kbps. Okay, so next is the PC card. What is this PC card? You can see it's similar to a kind of memory. That is, one system has a memory, some kind of memory stored in it. It can be accessed in the other system through this PC card, and it is usually for the notebook or the laptop, you can use this PC card. So these are the things about the expansion cards. Next is the ribbon cables, and I'm sure you might have seen this somewhere or the other inside the system, or even at least in your previous classes. So what is this ribbon cables? Ribbon cables is nothing but it's a flat insulated cables with flexible enough to fit in the areas with a little space. Okay, and this these are like see here, there are so many electrical lines bound together, right? These are actually, see, individual lines which are actually bound together, and we can call it as a bunch. Okay, so this whole thing is a ribbon, and this we can call it as a bunch. So why are these used? These are used to attach hard drive and CD-ROMs. See, there has to be a connection from the CD drive to the motherboard, I told you. See, they are actually a separator, hardware tools. So to connect this thing, we need a kind of wire, right? Because these work with the electrical signals. You need the wires to transmit the signals. So this is done through these ribbon cables. And not just the CD-ROMs and the hard drive, it is also to connect the external devices. How the external device is connected? Of course you need to connect external device to the peripheral, the ports that we have discussed before, but from the ports to the motherboard or the the processor to be connected, you need to have this ribbon cables. And also peripherals includes like your printers and any other peripherals that you're using with the system. And next is again for the expansion slots also. For expansion slot you will put those memory cards that we have talked before, like network cards or modems, whatever it is, and from there to again motherboard we need to be connected through this ribbon cables. And even the IO ports, that is input and output, that is like keyboard, mouse, all these things are connected. It's like the connection inside the CPUs are done through this ribbon cables. Okay, next is the memory chip. See, you might have heard of saying the computer if it is a 32-bit or a 64-bit, right? You are very familiar with it. So what does this 34-bit and 64-bit mean? It is nothing but the type of memory chip it is using. That is, there are two types, that is SIMM and DIMM. SIMM is nothing but single inline memory modules, and whereas DIMM is dual inline memory modules. How these are different, or what are these actually? See, this is nothing but a computer holds a program and data that are currently in use, and we know whatever currently in use, the data is stored in, or the data will be in what, in a RAM, that is random access memory, that is currently being worked on, right? So this is nothing but we call it as a we had seen in the motherboard the DRAM slot, right? For that we are actually fixing this scale like a structure. Okay, and it has, see, these are the memory banks. It has, see, 1 2 3 4 5 6. So these are the memory banks it has, and it varies from computer to computer. So it can be of two types, as I told you, SIMM, DIMM. So what are the difference, or what actually the SIMM means? So the full form it goes as single inline memory modules, and it comprises of RAM chips on a printed circuit board. Again, see, this is a circuit board, this green color whatever is there, no, this is the printed circuit board, and it is attached to a computer's motherboard. I had shown you the, see, this is where that is fixed. You actually pull this out, fix it, and again push it in, so it stands erect in this slot. So that is how it is fixed into the motherboard. And it's these chips are packed into small plastic or ceramic dual inline packages, that is DIPs, which are assembled into a memory module. So a typical motherboard has 4 SIMM sockets capable of taking either single-sided or double-sided SIMMs. So the size includes the size of the, like the memory modules include like 4, 8 or 16 or 32 or even 64 MB. So when it is 32 MB that is used with the processors, they have to be installed in pairs, that is with each pair of modules making up a memory blank. These chips support 32-bit data paths and are originally used with the 32-bit CPUs. So when it is single inline, if it is a 32-bit and you're using 32 bits in a pair, okay, so it also comes in a format like the 30-pin SIMM and 72-pin SIMM. Okay, so these are like the naming that we have given for them. And DIMM is how different from SIMM? It is a dual inline memory, that is it has 168 pins in 2 rows. Okay, and CPU retrieves information at a 64-bit compared to the 32-bit. So that is why that is a 16-bit transfer, and so that is why the difference in the physical would be like the length. Okay, the length of the notches, and the main difference of two is that opposing pins on either side of the board are tied together to form one electrical contact in SIMM, Whereas in a DIMM, the pins are electrically isolated from two separate contacts. And DIMMs are often used in computer configuration that support a 64M bit. Okay, so this is the difference between a SIMM and DIMM. Next we have is the processor. So we all know what is a processor, right? It is simply called the CPU, Central Processing Unit. No, the main thing it contains is a processor. What does it do, I think, actually? It is, we call it as a memory of the the brain of the computer, right? Why? Because all the things that has been performed by the computer is actually by a processor. Like it can be controlling, it could be giving the commands, whatever it is actually done mainly through the processors. So what are so we need to choose a processor. Actually, you get so many kinds of like so many are there in the market now, but how do we choose it? How do we choose a processor? Because as I told you, it's a one that main thing that a computer is dependent upon, right? Processor is the one thing that is computer actually is dependent on, based on like it controls every other thing in the computer, right? It is only the processor that is controlling every other thing in the system. So that is why when choosing the processor, you need to be careful, and what actually yields you the highest, you will choose that kind of a processor. So if you're choosing that kind of a processor, what are the things that you need to keep in mind? First thing is of course the performance. That is, it's a performance should be speed and accuracy. If you use a high-end processor, of course your speed will be the highest, and you will have the very accurate answers for your questions or the problems that you are having. And next is again the speed of the processor defines how fast it can perform the operations, right? That is, we say what a speed is about. And it also depends on the internal clock speed of the CPU. So if the internal clock is faster, the CPU will work again faster. And but the thing is, the hardware will be a little expensive because it need to cope up with that kind of speed, right? Then software support. So your processor should be such that it can adapt to new softwares, and it can uh, work faster with the new softwares as well. So software support by a processor is a must. So for example, if a new processor like Pentium 4 has used, it can use the special softwares which are not supported on the earlier machines, because it is a newer version. So new softwares can be supported by this. So it will have a very good software support in the system. Next is reliability and stability. You know what reliability means, right? That is, the system is reliable, or your processor should be reliable, and it should not break down in between. If something error happens or some kind of abrupt operations happens, it should not be, it should not black out, or it should not get off. So that is the reliability. And stability is again depends on the processor. That is how stable the processor will be when it handles so many applications with it, right? So it has to manage all the applications, and it should work diligently. So that is about reliability and stability. Next is energy consumption and cooling. Of course, this is one of the main thing, because processor is the one that actually gets heated up so fast, and because of this itself, the whole mother thing has this cooling effect, or the heat sink, whatever it is. So energy consumption, that is again the energy that is consumed through the power supply, and the system has to work in that power supply, and also at the same time it has to be cooled. So all these things are again managed by the processor itself. Like we should choose a processor that manages these things very well. And next thing is the motherboard support. That is, you cannot simply add any processor to the motherboard. The motherboard has to support that, like it should have the capacity to support that kind of processor in it. Only then you can use that processor. So only if the motherboard supports that kind of high end processors, only then you can use in your system. So this was all about the components of a inside a CPU. So that completes this unit. Thank you.